plane is looking like a winner.
Especially now that we put a rudder on our plane and we move the wings back.
It doesn't pitch.
And it doesn't bank anymore. But I wonder if we're still missing something.
Dr. D, we still have a few questions. You think you can help us?
Sure.
Thrust is needed even when the plane is going at a constant speed. Why is that? Does it have anything to do with drag?
Yes. Drag is what we call all the forces that act on an aircraft in the backward direction. Let's try an experiment. I'm going to push this cart. What happens?
It looks like it's not slowing down, but you didn't keep pushing it.
I didn't have to. Isaac Newton explained that once an object gets moving, it stays moving in a straight line at a constant speed unless you apply force to it. Watch this other cart.
It slows down right away. There must be some force acting on it.
That's right. An object will only slow down if a force acts on it in the direction opposite to its motion. What might that force be?
It looks like friction. That's the force when you rub two objects together.
Very good.
Does an airplane experience friction?
An airplane experiences a type of drag called air resistance because of the air flowing over the wings and other parts of the body. Have you ever tried to drive your bicycle into the wind?
Yes, it's really not very easy.
You've had some experience with air resistance.
So if the drag is less, then you won't need as much thrust to keep it moving at a constant speed.
Correct.
So if we can find a way to reduce the air resistance, we've got it made.
That's not exactly right, because it turns out in addition to air resistance, there's another type of drag.
This is getting complicated.
Okay, we'll take air resistance first. To understand how to reduce air resistance, it would be best to talk to an expert. And of course, the best expert is nature.
Nature? I wonder what that has to do with drag.
Well, I know someone who observes nature to understand drag, and he can tell you all about it. His name is Ben Anders. He studies birds, fish, and even insects.
That's our next stop.
Look over there. That man looks like he's studying the fish.
Dr. Anders, we're the treehouse detectives.
Oh, hi.
Dr. D said you could help us.
We're trying to understand the force of drag. Dr. D says you use insects and marine life to help you in your research.
Yes, I do. When I look at those shapes, I see airplane wings.
Airplane wings?
I guess I can see a slight comparison, but why would you want to compare them to airplane wings?
At NASA, we study birds and insects and marine animals to inspire new research on flight and on ways to reduce drag. And we call this biomimetics.
Wow, that's a big word. How do you do that kind of research?
Well, let me ask you this. What do you think has a lower drag, a smooth surface or one with grooves in it?
I'm not sure. I would guess a smooth surface would have less drag, but what's the right answer?
Well, normally a smooth surface does have lower drag, but if you make the grooves very tiny and you shape them just right, the groove surface has lower drag. And we discovered that the shark skin has those exact same tiny grooves to reduce his drag. I wonder what other secrets he's holding.
This is so cool. I wonder if we need to make some adjustments to our plane to reduce its drag.
Maybe we need to do a little more research.
Let's go back to the treehouse. Okay. Bye.
Bye.